In the Unit 3-4 review sheet, number 14, we have to find the angle, which we can call theta, the radius, let's call that r, arc length, let's call that S, and area, call that A. As needed until all values are known. We're given 2 of these pieces in each of these, and we need to find the other 2. So in part A, looks like we're given arc length. This line right here is the arc length, which is 30 pi. And we are also given the angle, which is this piece right here, which is 3 pi over 2. And we need to find area and the radius. So to find the area, we would need the radius. So let's find the radius first. And the radius, there's a relationship between the radius and the arc length and the angle because these angles are measured in radians, which means it's the number of radiuses that lie along this line. So how many radiuses can I fit on this arc length? That's the definition of arc length. So arc length is the radius. Wait, I already have arc length. I'm going to solve. Oops, sorry. I'm going to solve for, I'm looking for R. So in terms of arc length and angle, R is the arc length divided by the angle. Let me think about that. Yeah, that's right. How many arc lengths fit in that angle? Actually, I'll tell you how I was just thinking about it, because this helps me remember it. I know that arc length, that one's easier for me. I'm sorry, angle. Darn it. The angle is equal to how many radiuses fit into that arc length. So that is kind of how I remember it. And then, but I want to solve for r, so multiplying both sides by r and then dividing by alpha, I get that radius equals the arc length divided by alpha. So those are equivalent equations, but one of them is easy for me to remember and one of them is actually going to help me. So I'm using r equals s over alpha, which is 30 pi yards divided by 3 pi over 2. So those 3's are going to simplify. I'm actually going to write it out as fractions. So divided by 3 pi over 2 is the same as 30 pi over 1 times 2 over 3 pi. And then I can see those 3's will simplify. That becomes 1 and that becomes 10, and I'm left, and my pi's will cancel. So I'm left with a radius of 20 yards coming down from there. Okay, so this equals 20 yards. So that's one of my answers. My other answer I need to find, let's see, area is the other thing I'm missing. So area is all this orange area. And the formula for that is 1/2 r squared theta. I have r and I have theta, so I can really just plug and chug. So I get 1/2 r squared is the 20 that we just found. So that's 20 squared. And theta is the angle that we're given in green up there, which is 3 pi over 2. And then exponents first. Please excuse my dear Aunt Sally. So 1/2 of 20 squared is 400. and 3 pi over 2. So I have 2 factors of 2 in the denominator, which is 4, so I can cancel out 2 factors of 2 with that 4 to get 100 there. And I'm left with an area equals 300 pi. So that's my final answer for area. So this is my final answer for part A. And then going on to part B. I'll just squish that up on the left under A so I have some space to do part B. So in B, looks like we have the angle is, whoops, that's not a pen. We have the area, 864, and we have the radius of, angle of 3. 3 radians. And the things we need are surface area and, arc length for S, so arc length, and radius. So I can find, let's see here. Let's use our area, 864 millimeters squared, equal to our formula for area. And we have theta, so we can plug in our 3 for theta, and we want to solve for the r. So I have 864 equals 1/2 r squared, and theta is the 3. So I need to get r by itself. So I need to divide by a 3 and multiply by a 2. And it doesn't matter which order I do that. I could multiply by 2 first and then divide by 3, or vice versa, because multiplication is commutative, so I can switch the order. I'm going to go with dividing by a 3 first because I like making numbers smaller rather than bigger. So I find that easier to work with. So I'm going to start by dividing by 3. 864 is divisible by 3 because if I add those numbers together, it's 18, which is divisible by 3. So I'm going to divide that by 3. I get, 3 divided by 864 gives me 288. I still have that 1/2 there I got to get rid of. So to get rid of that 1/2, I'm going to multiply both sides by 1/2. No, I'm not. Just kidding. I'm going to multiply both sides by 2, or the reciprocal of 1/2. And I get that 1/2 r squared. Oops, sorry. The 1/2 is gone now. The 1/2 and the 2 cancel. I have r squared equals 288 times 2 gives me 576, which tells me that r equals 24. I'm just going to double check that. So if I do a factor tree for 576 to look for those factors, I know it's even. So I'm going to split that by 2. We already did that math, so 288. 288 is still even, so that divides into 144, and 144 is one that I know is 12 times 12. So it looks like I have 12 times 2 twice, which is 24 squared. So that r is 24. I know it's positive because it's a radius, so it's a distance. So now I have r, and I still need to find s. So that is this length. How many radiuses can fit into that line? So I have that formula is r times the angle, the radius times the angle, which is, radius is 24. Theta. And theta is 3. Which is 72. And our units are millimeters. Our units, the units on the radius are also millimeters. So there's my final answers. Although this one's kind of messy, I'm just going to fix that. So this should be millimeters. Final answers.